Hello, Algebra 1 students. Because some of you have missed and because some of you who were there may need a little bit of explanation, I'm making this video going over the concepts we've been talking about the last couple of days, particularly pertaining to inequalities. Okay, so you know we've done equations plenty enough. So if you have an equation, something like 3x plus 4 equals, say, 13. You know you're always going to do SAM, which I've told you a dozen times, more than that, which is simplify, add, which includes subtraction, and multiply, which includes division. So you do them in that order. You want to get the x by itself, or whatever the variable happens to be. So there's nothing to be simplified because there's no like terms. So then you go to addition, which includes subtraction. That cancels out the 4s. You have to do the same thing on both sides. So you get 3x equals 9. Then multiplication / division is the last step. You get rid of the 3 by dividing it. And then you have x equals 9 over 3, which is 3. Well, with inequalities, you have greater than, less than, greater than or equal, and less than or equal. And if you had gone through this and it had been, say, less than or equal, not one single thing about how you did that would change. It would be exactly the same. The only difference is, instead of being x equals 3, it would be x is less than or equal to 3. So I don't feel the need to elaborate on that very much because it's pretty much intuitive. What I do need to elaborate on, though, is the notation. So we got x is less than or equal to 3. Now, if we had x equals 3 from an equation, there's no reason to do anything beyond that. There's no point to graph it. The number is the only solution. That's it. But the thing with an inequality is talking about more than one answer. I mean, 2 is less than 3. 1 is less than 3. 0 is less than 3. Negative 50 billion is less than 3. And of course, 3 could work there because it says less than or equal. So there are 3 basic formats in which you can write the answer besides just this one here. First one is called set builder notation. This is not actually in your textbook, but you will see it if you take college algebra, most likely. I know that they always used it in the textbooks when I was at BCTC. I assume they still do. So it's good to see it whether it's in your textbook or not. Set build is the fanciest looking, but actually the easiest. And I wrote that wrong. It is the easiest form of notation because basically I just took what I already had over here and stuck these characters around it. The curly braces, and I believe I've said this before, indicate that the stuff inside is a set, which is why we call it set builder notation. And x slash, and I think one day that I was doing this on the board at school, I put a colon in instead of a slash. I don't know what I was thinking. This means x so that, or such that. So the way you read this, technically speaking, is x so that x is less than or equal to 3. So that's easy enough. This is a small side thing. Some students say the curly braces are hard to draw. They don't have to be. Just make an S, then make a backward S. That's all. Okay. Graphing is the next way you can write the answer to this. You draw a number line and you put 0 in. You don't need to do 1, 2, 3. You don't have to do all this stuff. All you have to do is put the number. The place you're at begins at 3. Put a dot. Since this is less than or equal to, you put a solid dot. Now I'll draw another example over here. If it had been strictly less than, if it had been x is less than 3, you would put an open dot because 3 is not included here. The open dot's like you just punched out the area with 3, everything else works. In both cases, and I will change colors so you can see it more clearly. In both cases, we then an arrow to the left because this is less than 3. So you're going downward. And in fact, the direction your inequality sign points, as long as x is on the left, is the same as a line. So that's pretty easy to do. Now, the third way of doing, well, actually, let me back up. Another way you can do this like dots. And why wouldn't you like dots? But if you don't like dots, you could use a bracket. So a solid dot is the same as a bracket, square bracket. And then you could use a round parenthesis. That's a pretty bad looking one. Could use a round parenthesis here. So the open circle and the round parenthesis mean the same. Okay, so interval notation. You take whatever's on the left and then put a comma and then whatever's on the right. Since this goes downward infinitely, negative is on the left, 3 is on the right. This bracket indicates that 3 is included. You know, I like using the dot better than I do the bracket when I graph these, but some textbooks, once again, the textbooks that use the BCTC, show it that way. So I want you to be exposed to it. And it actually does help if you're graphing because you don't have to wonder what to use in the interval. You just drop it down. Infinity, boy, that's a really bad parenthesis. Infinity always takes the parenthesis because it's never included. It never ends. So it's always open on that end. This is called a half open interval because it's open here, closed there. Or you could call it half closed. You know, I see the old thing is the glass half full or half empty, depends on your point of view. Is the interval half closed or half open? Well, you know, whatever. This does the same thing, but in this case, it's a fully open interval because 3 is not included either because it's strictly less than. So, to sum up, once you've got your answer as to what the inequality solves out as, you can write that answer in set builder notation, or you can graph it, or you can do interval notation. And with the intervals, a solid dot and a bracket mean the same thing. Open dot and a parenthesis mean the same thing. And of course, if you had, say, if this had been the other direction, then that would change to match it. And then the bracket would turn the other direction, the arrow way, and you'd write the interval then bracket 3 up to positive infinity. So this one is the one students usually make the mistake on. They want to write this as if it was that, but you're always reading from left to right. Okay, so the other thing I need to tell you about is compound inequalities, conjunctions, and disjunctions. Okay, so like I could say x is greater than 2 and x is less than 5. So two things happening at once here. It doesn't look very good. So on the one hand, you could say that x is strictly greater than 2. Open circle on 2, or you could use a parenthesis and infinity. Then x is less than 5. That has an open circle, and the 5 goes to infinity to the left. But the key word here is and. So this is the stuff that we're actually interested in. This plain green area here, right over here, doesn't interest us because, yeah, it's bigger than 2, but once you get past here, it's not lower than 5. Then this red area we're not interested in because, yeah, it's less than 5, but it's no longer bigger than 2. So it has to be both conditions met simultaneously. So what is really the way you want to do it, the place where the green and the red overlap, but you can write it in one simple way. Open circle or parenthesis on the 2, open circle or parenthesis on the 5. Between you don't need the rest of the arrows going off to infinity because they are irrelevant to this. An and statement like this is sometimes indicated by that symbol, which is called a caret, not what Bugs Bunny eats and not like how much your diamond weighs, is spelled differently for both of those. Or if you want to be really Slavic about it, sometimes they call it a hachek, which is a Czech word. So you could also write it like a croquet wicket or an upside down U. And I believe when we were talking about set theory a little bit at the beginning of the year, I believe we've done this before, but it's been a while. This is called conjunction. Conjunction, junction, what's your function? Yeah, if you're watching this, Sarah Beth, I did it again. So, junction. Junction means unifying, coming together, like a junction of a road. Con means with. So coming together with, which is what and really means. And conjunction means two things are happening at once. It has to be bigger than 2, and at the same time, it has to be less than 5. Okay? This interval is completely open because neither side is included. You could have something like this. So let's say x is greater than or equal to 4. And I'm going to use the conjunction symbol. And x is less than or equal to 8. So here you have 4. Here you have 8. And you darken the place in between them just like I did before. But this time, it'll be different you have dark dots, or you could have square brackets on each side. 4 and 8 are both included. So this is a fully closed interval. It's closed here, closed there. Now, the last thing is to write it in conjunction notation is a bit inefficient. It's easier to say it like this, to say and this is for the one on the left, this one here. Or if I were going to write this, I would do like this. So you have a compound inequality. I turned it around. You always put the x in the middle in cases like this. Notice that the inequality sign opens toward the x in both cases and points toward the 2 in both cases. So when I change the order, I have to take the inequality sign with it. But this expresses that. X is between 2 and 5, just like it's shown here, just like it's shown there. So 2 is less than x, which is less than 5, or in this case, 4 is less than or equal to x, which is less than or equal to 8, because x is in between 4 and 8, and in this case, it can include them. Okay? Now, sometimes you will have a compound inequality written in such a way that it needs to be solved. So you might say 15 is less than 3x plus 6 is less than or equal to 21. Now this is a half closed or half open interval because it's open on the left and closed on the right. You might look at this and think, but it's not that bad, really. You know, when you're doing an equation or inequality like this, you know, the rule is what you do on one side, you do on the other. Okay? Well, all that happens here is you're increasing the number of sides. Instead of 2 sides, you have 3 sides. You always want to start from the middle, always. You start from the middle and then go both directions. So, for example, I want to get the x by itself, just like I do in any other situation like this. So I have to get rid of the 6, and I do this over here, just like with a regular equation or inequality. But now I have to do it over here also. So I'm doing it 3 times at once. 15 minus 6 is 9, and 21 minus 6 is 15. So I've got it down to where, and by the way, Sam, I'm still doing Sam. No simplification needed. I do the addition or subtraction first. Finally, the multiplication or division. To get the x by itself, I divide out by 3 on all 3 sides. 9/3 is 3. That cancels and gives me x. And then 15 divided by 3 is 5. And so if I were to graph that, then I would have 3 and 5. 5 is closed. I'm going to use a bracket and parenthesis notation this time just for variety. 3 is open, and that is what you would get. Okay, so that's all. The last thing I want to talk about is disjunction. So if I said x is less than 2 or x is greater than 5. Or you just reverse all the symbols from and. Instead of a caret, you have a V. Instead of a croquet wicket, you have a U. And this is called disjunction, which means pulling apart, unjoining, which is exactly what it is. So if I were to graph this thing on the number line. Well, in this case, it's strictly less than 2. So it looks like that, going the same direction as your sign. And it's greater than or equal to 5, goes to the right, same direction as the sign. Now, in this case, there is no common ground. When we did this with the conjunctions, you had the two lines crossing over each other. Here they don't. But that's okay. See, this could not be an and. If this was and, you can't be less than 2 and greater than 5. That's not possible. You get the null set, the empty set. But or is fine. You can be less than 2, or you can be less than 5. Now, it's actually worthwhile to point out that there's actually two different kinds of disjunction. If I said x is less than 8 or x is greater than 5, we set this up the same way, but it's going to look a bit different because now you're going to have less than 8, which looks like that. And then you're going to have greater than 5, which looks like that. So in this case, there's no crossover. In this case, there is crossover, but they're both or statements. So since this includes all the red line and all the green line, it would just be in interval notation everything from negative infinity to positive infinity. Or you could do this, which is a symbol for real numbers. It's all real numbers. Here, though, you would have to say negative infinity up to 2 union with, or if you didn't want to use that symbol, you could use the little v, union with 5, and actually, I wasn't paying attention. I can't use parentheses there because it got an or equal to in it. So actually, 5 with a square bracket up to positive infinity, which of course takes the round parenthesis. So in this case, this is called, whoops, hit something wrong. This is called strong disjunction, and this is weak disjunction. Strong disjunction means that there's no overlap at all. They have nothing in common. You got this red stuff over here, you got this green stuff over here. They don't interact. You're just in one or the other area. And in non-mathematical terms, an example of this would be like alive or dead. You can't be sort of alive or kind of dead. You're one or the other, period. Or, a negative number or a positive number. You can't be both negative and positive. You're one or the other. There's no middle ground. But sometimes you can have a middle ground. That's weak disjunction. So I could be a teacher and I could be you say somebody's a teacher or a man. Well, I'm a man and a teacher. I can be both. You're a person and you wear glasses, or a person or you wear glasses. You can be both. You can be a person who also wears glasses. So some ors, or, not or of a boat, but or, some ors can happen at the same time. Like if I said I'll have hamburger or pizza, well, I could have both. But Other ors are either or, one or the other. Like either I will eat today or I won't. Well, I mean, if I fast, I'm not eating. If I'm eating, I'm not fasting. So they can't both happen at the same time. I did not go over in class how to actually work disjunction problems. We'll try to do that whenever we get back to in-person school. And this covers, I believe, everything that I've talked about really this week. So I'm going to post it on my YouTube channel, and I will email you the link for it before I go to bed tonight. I hope this is helpful to you. If you do have any questions or any clarifications you need on this, please let me know, and we'll go from there. So stay warm and stay safe on this snow day coming up, and I will hope to see your smiling faces as soon as possible. Bye.